Okay, hi guys. So in this lecture we'll be taking on some examples. Okay, so the first question is you have to write the um, procedure via which you can convert uh, one compound into the other. So you have to write down all the mechanism and the steps. Okay, so let's get started. So we have the first compound as you have to convert. Okay, first let me write down the question. So convert the following. Okay, so first you have to convert benzene into 2 fused benzene. So how will you going to convert this? Take a pause in the video and just draw on a paper how would you go about converting it, or just think for a moment how would you actually convert it. It's actually very simple. The first step would be obviously to react it with Cl2 in presence of AlCl3 to get chlorobenzene, and when we react it with sodium in presence of dry ether. I hope you remember this reaction, and also hope that you keep revising your previous set of organic chemistry lectures. Okay, so in presence of sodium dry ether, it will get converted into 2 phenyl rings. Okay, we aren't going to discuss the mechanism in depth. We are just going to discuss how a product can be converted into another product via reagents. Okay, I hope you remember the mechanism, and you are fully thorough and revised with all your previous concepts. Okay, so this could be method 1, right? And okay, so second example is uh, we can actually prepare this via one more mechanism. So we can have actually something like if we prepare this, and if we have something like pH MgCl, and we have this compound as chlorocyclohexane, then we can have something like pH and this compound. Okay, and then what will happen is, if we react it with selenium and we heat it, we saw that it would actually unsaturate the cyclohexane, and it would prepare the phenyl ring from the cyclohexane ring. Okay, so the second example is we have something like a benzene ring, and we want to make CH2Cl from this compound. Okay, so how can we actually make it? So obviously we can actually have Cl2 in presence of AlCl3, make it chlorobenzene, and from chlorobenzene we can actually uh, have something like okay, so first from chlorobenzene you can actually have something like in the presence of Mg in ether presence, you can have something like okay, so forget about the Cl part. You can actually have Br, because ether is MgBr. Okay, so R MgBr is would be there, and you can react it with in presence of Br and Fe. So pardon me for Cl in presence of AlCl3, you can have Br in presence of Fe. Br, sorry, presence of Fe. So we can have something like this. This is a Grignard reagent, and then we can actually react it on something like CH2, rather CS3 only. So CS3 Cl. Now that will attack on this. Cl will actually remove itself from the C bond, and we would have something like this compound. A toluene is formed, and MgBrCl. Okay, so Again, you can actually have Cl2 in presence of H nu. It will convert itself into CH2Cl via free radical mechanism. Okay. Another thing is you can actually have Grignard reagent from, this was the first method which I wanted to um, write, and the second method we can actually have Cl2 in presence of AlCl3 as well, which I erased in the previous example, but we can actually make it again. This is the second example in which we are creating a different type of Grignard reagent. Okay, and now the rest of the reaction remains the same. Third, how can you prepare it with the third way? We can actually have a benzene ring, and we can actually have CH3Cl directly, and we can use AlCl3, or for direct craft acylation, alkylation, we can have CH3 here. Now once this is there, we can actually use Cl2 in presence of H nu. We can directly make CH2Cl. Do you know another method? Yes, you can actually prepare the same product by using CH2Cl2 in presence of AlCl3, and we can get something like CH2Cl again. Okay, so let's now look at another example where we have a matrix question. Okay, so you need to match the left column with the maximum possibilities in the right column. So let me first write the right column first. So W is electrophilic substitution reaction. Wx is free radical substitution. Okay, let me write it fully only. Y is dehydration reaction. And Z is, we have carbocation is intermediate. And Z dash is carbanion is intermediate. Okay, so on the left hand side we have something like a benzene ring which undergoes HNO3 and H2SO4. Okay, so what are all the matching criteria in the left column for this A reaction? Obviously there would be electrophilic substitution. This is an example of sulfonation. Okay, so SO3H would be added to this compound, it would be electrophilic substitution reaction, and another is carbocation would be the intermediate. Okay, let's see B example, wherein we have this group and this undergoes Br2 in presence of water. Okay, so what all will be the answer here? Obviously it's a electrophilic substitution reaction. Br would be added in all the ortho and para positions, not meta positions, and carbanion is the intermediate. So is the carbanion intermediate or the carbocation is the intermediate? I hope you all guessed this correct this time, because we saw so many examples of phenol reaction with Br2 in water. So carbanion will be the intermediate. Okay, I hope you remember this form, that we had something like this. Okay, and in which this was acting on Br. Okay, and in the next step we would have something like this, Br here, H here, and double bond O here. Now in presence of again water, this will react on this, will have a negative charge here. It will form or restore the aromaticity in the benzene ring again, and the O will take its minus charge again, and this H would be again attacked by O. Okay, so the answer would be W and Z dash. Okay, let's see C example. We have something like OH here in presence of H plus, and we are heating it. So what would be the answer here? Obviously it's an example of electrophilic substitution reaction in which 6-member ring would be formed. It's an example of dehydration. Water molecule would be removed from this. Okay. It's an example of, obviously, carbocation would be formed. Okay. Now let us look at the D example. We have something like, I'm just drawing D example over here. So we have this compound. This is undergoing Cl2 in presence of H nu. Okay. So obviously only free radical substitution reaction is there in this compound, as we saw that Cl2 in presence of sunlight will be having a free radical mechanism. Okay. Now actually let us see another example wherein you need to tick all those. It's a multiple choice question. Okay. So Br2 in presence of H2O will react with which of the following compounds? A is, you have phenol. B, you have aniline. C, you have unsaturated cyclohexane or cyclohexene. And D, you have let me redraw it. D, you have alkene. Okay. So now obviously we have seen so many examples. Okay. So this will undergo reaction. Okay. Aniline will also undergo reaction because it forms more stable compound in water with N minus here. Okay. C, obviously you will have formation of halohydrin. Okay. I hope you remember the reaction in which we will have something like Br2 will actually make a 3-member ring with these two carbon atoms, and this ring would be aromatic in nature. Okay, that's why it's so much stable. Okay, and then the water molecule will attack on from the back end side, wherein, or from the opposite side wherein the Br is attached. Okay, and it will form a halohydrin like this. Okay, so it will undergo reaction. What about alkyne, sorry. So talking about alkyne, what would actually happen is we would get something like this, and in presence of Br2 in water, we would get Br2 would obviously be, Br plus would obviously be attacked by the alkyne group, and we would get something like Br here, double bond here, positive charge over this. Do we really get a positive charge? Yes, and afterwards OH minus will attack on this, hence we will be getting something like Br here, C double bond O and CS3, which can undergo tautomerism in acidic medium, and we will get something like this as our final product. Hence Br2 in presence of water will actually react with this compound. So all will react with Br2 in presence of water. Okay, so let me write down an important note at the end of these lectures is presence of carboxylic acid or sulfonic acid at ortho or para position of phenol or aniline reacts with Br2 in water, and ipso substitution takes place. Okay, so presence of carboxylic acid and sulfonic acid at ortho or para position of phenol and aniline when reacted with Br2 in presence of water would undergo ipso substitution. Okay, so with this we come to an end of this lecture, and in the next lecture and from the next lecture we will be seeing nucleophilic aromatic substitution reactions. Okay, so till then, good luck and goodbye.